Hey, in computer science, a black box refers to a system where both its inputs and outputs can be viewed without any knowledge of its internal workings. This can be highly problematic, and particularly with the rise in popularity of artificial intelligence, is something that's being seen more and more frequently. Today on Lokad TV, we're going to be discussing the solution, something that is known as whiteboxing. So Johannes, before we get on to whiteboxing, perhaps we should start off with the black box problem. So what is it about black box and what is the problem here?
Supply chains are complex systems. So a lot of people are involved, a lot of products, potentially a lot of locations. So from the start, it's a given that it's a very complex problem, and thus a problem that already has its own opacity, just because it's very complex. So it's very hard to grasp the whole thing. Then when you add, I would say, layers of software in the middle, it just makes the problem worse. And I'm only talking of relatively basic software that is just, shuffling data around, the plumbing parts of your supply chain IT. Nothing smart, but even that creates another layer of opacity. Now, what is happening? People are, some vendors are advertising AI, but I would prefer to think of, I would say, smart advanced numerical recipes for supply chain. And as soon as you add, I would say, non-trivial numerical recipes in the middle of your software that is actually driving your supply chain, then it creates, I would say, a whole new level of opacity. Because before, the software was maybe complicated because tons of accidental complexity. It has to communicate over the internet. It has to be compatible with so many formats and whatnot. But that's right here, that I would say, accidental software complexities that only reflects the inner plumbing of the software, not the actual complexity of the supply chain.
Okay, you're mentioning quite a key word there, which is opacity. And perhaps it'd be useful to just sort of expand. What do you mean by opacity? What are we actually meaning by this?
Opacity, I just mean that for people in the organization, people who are working in the supply chain, who are organizing the supply chain, when I say opaque, I say that something is happening or a result is coming out of a system or measurement. And it's very hard to figure out exactly what this number means, where it came from, why it's actually set to this value, not another value, etc. So there is like, it's very hard. I would say the opacity is kind of the reflection of how hard it is to get to the bottom of things, whatever you want to investigate in your supply chain.
Okay, so when we basically talk about a black box problem, it's basically results are coming out of a system and we're not too sure where those results come from. So how sort of widespread is this problem? Is this something we're seeing a lot in the sort of the supply chain industry?
Yes. I would say the old ERPs and old systems they were very opaque for plenty of reasons, because at the time it was much harder to design, I would say, good relational schemas for databases. So their internal setup can be a bit messy. You can have, if you have a complex supply chain, you can have many systems that are not well integrated. So it's not that complex for any single part. It's just when you put all of them together, there is like a significant mess, and there is a lot of ad hoc integrations between the systems that are, I would say, not so correctly documented. So again, that's kind of emerging opacity out of systems that are individually relatively simple. Yet, and then when you put, I would say, numerical recipes, again, the opacity skyrockets, because suddenly you cannot, it becomes very, very hard to validate whether the numbers are correct. It's not about I'm checking on the central system the stock value that I should have in a remote location, and then I check in the system of the remote location itself that the stock value matches, that the both value do match. That was, sometimes it could be tricky and tedious to do this sort of checks, but as long as there is no numerical recipe involved, you could do it. As soon as you have like a linear regression model in the middle, it becomes like hell to even replicate anything and frequently even to understand what is going on.
So I guess that's what's kind of changed between those sort of older ERP systems and sort of the more modern ones, is we're now using sort of more complex numerical recipes. So is that the big change? Is that why this black box approach is kind of occurring?
I mean, typically those advanced numerical recipes, they don't typically live in the ERP. I mean, the ERP, despite its name, Enterprise Resource Planning, it has very, very little to do about planning. I mean, almost nothing at all. It's all about management. So you have Enterprise Resource Management, which is typically intended with zero intelligence by design. You just want to track your assets, and you have layers of analytics on top. But then you're correct in the problem. Within those layers of analytics, you have advanced recipes that some vendors might call AI, and yes, it becomes way more opaque.
Okay, and how about maybe like a real world example? How are these sort of black box sort of problems really affecting companies in the real world?
I mean, in the real world, what is surprising is that you don't need AI to get a black box effect. I mean, it's like some stuff that are much simpler are already, I would say, causing widespread black box effect. And what is happening is that I've seen many companies where even for something that is supposed to be as simple as a safety stock calculation, which is just how much stock you need to keep if you assume that your demand is normally distributed, so you have some uncertainty that is normally distributed on top of your forecast, and same thing for the lead time. Even there, they end up with, I would say, black box effects where say, well, I am entering a service level of 99.9%, but then measurement shows in reality that I'm only getting 97% service level. So you see, you end up with a bizarre disconnect between the setting that you enter in the system, like 99.9, and what you get in reality, which is 97. Mm-hmm. And that's the sort of situation where, well, you have a black box, you don't really understand what is going on, and clearly the output of the system does not match what you expected from the system. So you're facing this black box effect, I would say, heads on.
So if this is so widespread, I mean, how are companies overcoming these problems? How are companies overcoming that kind of discrepancy?
I mean, typically they overcome it with truckloads of Excel sheets. How do they, what happens when you have numbers that you cannot trust from the system? Well, people just extract data from, let's say, ERP, foundational data that they can trust, just the basics, stock levels, historical sales, historical purchase orders, this sort of things, very, very basic. They can double check that their Excel sheet is aligned with the system, so no black box effect. Even double check that what they have in their Excel sheet is actually aligned with what you have on the shelves in the warehouse, physically, just to be sure. And then start crafting your own numerical recipes in the Excel sheet itself, where basically the supply chain practitioners has control over the calculation at every single step, and it's very visual. So that's how they kind of try to stay away from a black box effect, although when an Excel sheet is passed from a supply chain practitioner to another, over the years, you can end up with some degree of opacity and black box effect in those Excel sheets themselves. I mean, Excel is not like a silver bullet. It just helps. Okay,
before we get on to too much Excel bashing, as we seem to do most weeks, let's talk about maybe the solution. So the solution is whiteboxing. I could probably guess where the names come from, but why is it so different? What is different about a whiteboxing approach?
I mean, whiteboxing is a practice that emerged at Lokad from our observation that even semi-trivial numerical recipe, again, just a simple safety stock formula, anything that is slightly more complicated than the moving average, and actually even more fancy moving averages, is a black box. So it doesn't take AI to get a black box. I mean, any linear model where you have 3 variables, most people in their head are not able to compute, 3 multiplication then that are summed together if numbers are large. So you can't do that in your head. So even a model that is as simplistic as a linear model with 3 variables gets very quickly relatively opaque to people who are actually crunching or using the results of this model. So as soon as you move toward anything that is smarter, especially anything that would capture like the non-linearities that you have in supply chains, it gets opaque pretty much by design. So what you need is a process, what we call whiteboxing, that is completely geared toward the idea that you will recreate, understanding and transparency and insights, knowing that by default what you get is pretty much the opposite. And there is no alternative. If even a model as simplistic and oversimplistic like safety stock is already opaque, you cannot have any hope that a better, more realistic model, such as based on probabilistic forecast and the probabilistic assessment of risk for your inventory, will be any less opaque. Quite the opposite. It will be more opaque, a lot more accurate. Thus, we need this whiteboxing process to create understanding and ultimately generate trust and ultimately have people giving up for good reasons on the Excel sheets.
So how does that actually work in practice? How do you go about actually checking the results that you're being given and having that real white box approach?
So one tricky aspect is that it's very easy to have people droning into walls of metrics. So generating numbers, you see, when people are facing a black box, the main, a frequent reaction is to say, oh, give me more indicators, create, KPIs, I want to see more. And then when you do that, and companies, when they face this sort of black box, they are trying to, extract KPIs, extract indicators, more. And what you end up with is gigantic tables with dozens of columns that are still completely opaque, but now I would say also incredibly complex. I mean, they are adding complexity on their own on top of the system. Just the reporting and the I would say the forensics efforts when trying that. So the starting point is to say, no, we need to have few numbers that are exceedingly well crafted when we want to try to explain decisions. So first, also one idea is that you don't want to try to explain everything, especially I would say numerical artifacts. You don't really care how some intermediate step of the computation is happening. What you care about is the end result. The end result is, for example, the decision that has a physical impact on your supply chain. You decide to produce, you decide to purchase more, you decide to relocate inventory from a place to another. That's the end game. So that's the decision you're concerned about. And then the whiteboxing is about, for every single decision, to have maybe half a dozen of figures that explain these decisions, measured in dollars or in euro. And the second idea is that why dollars and euros? It's because it's a thing that will make more sense company-wide. So that if you know that why am I purchasing 100 more units of this product, and you have a variable that say, well, the risk of stock out is 50,000 euro because if we run out of this thing, the production line will stop. So the cost will be, the stock out cost can be actually much higher than the value of what you're purchasing if you're putting, a production line at risk. So that's the sort of things that are the insights that people will get.
Yeah, so those sort of dollars and euros that you talk about, they're sort of the economic drivers that we apply. So what is it about those economic drivers that are so useful?
The economic drivers are extremely useful because they are comparable, company-wide. Because you see, the thing is that, okay, you have one decision where you have half a dozen of economic drivers, and you have another type of decisions with other type of economic drivers. And you want that by default, all your measurements to be kind of compatible and comparable, so that you can compare, apple to apple and oranges to oranges. If you have apple and oranges, then you're kind of lost. And that's typically what is happening with all those percentages of error. I have my forecast with percentages of error, and then is it good or bad? Well, it really depends, and you end up with all sorts of bizarre effects.
Other than those economic drivers, what is it about a Lokad approach that makes whiteboxing so possible? I mean, how does it differ from other techniques?
You need tools to do that. I mean, and I would say, most analytical systems don't do, I would say, such a good job at supporting a whiteboxing effort. Excel is actually quite good because you stay very, very close to the data, but it falls apart when the complexity and the volumetry of the data increase. So basically, Excel is absolutely excellent and as long as you're dealing with, let's say, less than 10 columns and less than 1,000 lines. If you start crunching millions of lines and dozens of columns, it will rapidly become like a gigantic spaghetti code base within your Excel spreadsheet. So basically, Excel is very good at I would say at limited scale, but it falls apart when you're facing complexity. And many systems, I would say analytical system, do not manage to preserve any kind of the property of Excel, and so it gets the data gets very far from the user. At Lokad, we have engineered Envision, which has the term vision in the name of this programming language, stemmed from the insight that we needed to stay very close from the data, so that we can do all those Excel-like validations all the time. And Envision makes it very easy when you craft formula to basically plot, through in a dashboard all your numbers, so that you can check, just like you were doing in Excel, those numbers just for validation, for the sake of validation. And so the idea we can generate dashboards that are highly composite, where you have your main drivers that are going to be displayed in big, but you can have many what we call small tiles that contains all your checks, just like you would do in Excel, so that you can check that your calculations are sane and that your intermediate steps are not completely out of whack.
Okay, let's start sort of drawing this a bit together now. If I'm a company and I'm using a piece of software that's exhibiting a lot of those black box characteristics, what should I be doing? What should be the first step I should do to sort of improve my understanding about what's going on?
First you need to have a thorough documentation of what goes into the system. Usually the documentation is inexistent. And just as a rule of thumb, what are we talking about? If you have a field in a table, that requires about 1 page of documentation, not IT documentation, but supply chain, business-driven documentation. So typically when we start, working with clients, at best, if every field has 1 line of documentation, we are happy. Usually there is like 20 tables, each table 20 fields, and we barely have 1 line of documentation per table. We should have 1 page of documentation per field. So that's probably the starting point for most companies, is to thoroughly document what you have as input of the system. Otherwise, you end up with garbage in, garbage out. Then, second thing is to check that your data crunching layer, your analytical layers, gives you basically the sort of agility that you have with Excel, so that you can, add in a few statements, add some lines of code. Unfortunately, you can't avoid the coding aspect, because just like Excel, it's about formulas and whatnot, so it's coding. But that within a few lines of code can let you add all those easy, I would say, reporting columns that you will need to debug your logic. So if you don't have a system that supports such an agile process, where you can, just like in Excel, create columns that are just there to double check intermediate calculation and whatnot, then basically game over. You will never get to the bottom of it, of your black box. So probably here, that's a step where you need to change the analytical layer. If you have that, is this, I would say, a layer, analytical layer that gives you some kind of agility. Then the next step is to start crafting very good economic drivers. So and by very good, I mean that every single driver needs to be as independent from the other drivers. So you want to have things that are very orthogonal. That's a danger, is that if you do not manage to craft, a series of indicators that are reflecting things that are literally orthogonals, then you might be looking at the same thing multiple times, and so you'll be misled. So that's a bit a tricky part, but the idea is that when you look at an economic indicator that tells you 100 euro of cost or reward, you want to make sure that it's as independent as possible of another driver that also claims to bring 100 euro of reward of cost.
Okay, so the key points there are really sort of understanding your inputs and your outputs, and also assigning those economic drivers. As a final sort of word today, why is whiteboxing so important?
I mean, it's so important because otherwise all your efforts at optimizing your supply chain will go to waste, because people will, for good reason, fall back to their Excel sheets. Because if you do not have a whiteboxing process in place that gives everybody the reassurance that everything that is coming out of those systems are the results are sane, then the odds are overwhelmingly that your results are insane. And so people do the thing that is sane, which is not to trust those results, and fall back on their Excel sheets. The Excel sheets are unfortunately the necessary solution against, I would say, system insanity. So whiteboxing is required. Otherwise, don't expect your teams of supply chain practitioners to give up on their Excel sheets anytime soon. They will not. And by the way, by not doing that, they are saving your company, because trusting insane system is much worse than wasting time on Excel sheets.
And who knew? A lot of analysts would probably think Excel gives you insanity, but there you go. So that's everything for this week. Thanks very much for your time. And we'll see you again next week. Thanks for watching.